Hi everyone, I'm going to explain to you example 20. Now for the first part, we are supposed to find the definite integral of the integral of 1 to 2 of x squared dx. Okay, now this is what we're going to do. Now the integration of x squared will be x cubed divided by 3, and the limits are from 1 to 2. So we're going to substitute when x is evaluated at 2 first, after that followed by 1 is what we know. So we're going to have 2 power 3 divided by 3 minus 1 cube divided by 3. We're going to get 8 over 3 minus 1/3, and we're going to get 7 over 3. Now for the second part, right, we are supposed to find cosine, the integral of cosine x, evaluated from negative pi over 2 to pi over 2. Now the integration of cosine will be sine, okay, and this function will be evaluated from negative pi over 2 to pi over 2. So we are going to find sine pi over 2 minus sine bracket negative pi over 2. Now sine pi over 2 will be 1, and sine minus pi over 2 will be negative 1. So we are going to get the value of 2. Now for the third one, okay, we're going to find the integration of 1 over 2x, and we're going to evaluate it from 1 to 2. Okay, what I'm going to do now is that I'm going to take out half, because half is just a constant multiple. Okay, so the integration of 1 over x will be the reciprocal, right? 1 over x, so we're going to be ln. So evaluate 1 to 2. So we're going to substitute, and ln 1 is 0. So we're going to have half ln 2. Okay, we're going to move over to example 22. Okay, now the question is, we are given in part 1, okay, this is the question. Given that y equals to 2x minus 1 product with a square root of x plus 1, show that the dy dx is this. This is actually from your previous topic. And then hence evaluate this integral from 0 to 2 of 6x divided by square root of x plus 1. Now for the first part is what you have been doing for the last topic on differentiation. Okay, this is a product function. So we are going to take the first function, differentiate the second function, and remember there's a chain of 4, and then take the second function for x plus 1 power half, and then differentiate to x minus 1, we're going to get 2, and then we simplify, we are going to get this, and we are going to factorize the 4x plus 1 power negative half, the lower of the two powers. So, and also the 2. Okay, we're going to have this. So the first function we're going to have left 2x minus 1. And the second function here, we're going to have 4x plus 1 power 1. And power is just for x plus 1, right? So when we evaluate or simplify the one in the bracket, we're going to have 6x. Okay? So eventually, we're going to have this, because there's a 2 here. We multiply, we're going to have 12x over square root of x plus 1. This is what we need to show. Now for part 2, right? Please take note the word is hence. We got to use part 1 to evaluate part 2. If we got y here, and we differentiate y, we got this. So we should be able to see this. So the integration of 12x over square root of 4x plus 1 with respect to x, right, will give you back the function. And remember, this is plus c. This is still an indefinite integral. Okay, we need to write plus c. And then please take note. If you put the 6x, right, you realize that this is 6x. Okay, so in other words, we are going to divide this by 2. Now what happened to the c? The c will be eliminated. Because once at the definite integral, we don't write the c anymore. Okay, now how do I get this? Because once I get this right, I evaluated this function at 2 first. I'm going to have 2 times 2, 4, 4 minus 1 is 3. 4 times 2, 8, 8 plus 1 is 9. So square root 9 here and divide by 2. And in a similar fashion, if it's 0, this is going to be negative 1. And this is going to be square root 1 over 2. Please take note that this is a difference, a minus here. So when we evaluate this, we're going to have this. This is 4.5. This is minus. This is negative 0.5. We're going to get 5. Okay. Now that's how we do example 22. Okay. Now let's move on to example 23. Okay. Now in example 23, right? Okay. The differentiation of this is the product. So we take the first function, differentiate the second function, take the second function, differentiate the first function. We're going to have this. Now in similar fashion, we need to actually hence find in part 2, right, the integral from 0 to 1 of this function. Okay. Now, okay, let's look at how to do the part 2. Okay. Now in part 2, right, I'm going to show you what you normally do. Okay. Now, if this is true, right, can I just move up? Okay. If this is true, what we can see is that this one, right? Okay. If you integrate this, so I have this. So this will be the integration of this, right? Correct? Now, so next, what do we do? I still write the left hand side here. I'm going to take out the constant 2 here. I left this, and I'm going to break up into these two integrals. Okay. Now after that, I'm going to rearrange. Okay. Please take note. My question is this. Integral of this function is somewhere here. Okay. So I'm going to put this on the left hand side. Okay. Of course, this is 2, right? Okay. Please take note, if I were to, this is just a manipulation. This is just a manipulation of this. I just rearrange. Okay. Then what I do is that I'm going to please take note, there's a plus c here. Whenever you do this, right, remember there's a plus c. Okay. Once you integrate this, right, this will be e power 2x divided by 2. Okay. And there's I divide 2 throughout, right? So this is going to be half x e power 2x minus half, and then this, right, integral of this will be e power 2x divided by 2, and then there must be a plus c here. This is still an indefinite integral. Okay, what do I do now? I'm going to evaluate this. This is just minus 1 quarter e power 2x plus c, and then I put the integral sign. Sorry, the limits to the integral, 0 to 1. Okay, so I'm going to evaluate this from 0 to 1. At this step, the c disappears. So you must know when you need to write the c and when you need not have to write the c. Whenever you place the limits to this integration, the c will disappear. Okay. So what we have, we are going to put evaluate this at 1. We're going to have half times 1, half e power 2 minus 1 quarter e, 2 times 1 will be 2, and then at 0, right, this is going to be 0, and then 0, this is going to be minus 1 quarter e power 0. So we just simplify. We're going to have this. This is just 1 quarter e power 2, and this is going to be plus 1 quarter. Okay, and we got this. Okay, I'm going to show you a shortcut. Okay, this is called a method 2. Just to bear in mind, the first 2 steps is exactly the same. Okay, so when is the difference? Do you notice that this first 3 line is the same as this first 3 line? Okay, it's the same. Okay, but what differs is that I'm going to actually just integrate this, and this must be a plus c here. Okay, and I do not want to divide by 2 throughout. Okay, I'm going to do that right at the last step. Okay, this is what I put the limits 0 to 1. I evaluate this. Okay, and I will get this is 1 e power 2 minus e power 2 divided by 2, and again this is 0 because when 0 times anything will be 0, and e 2 power 0, so e power 0 is 1, so we're going to have this. Okay, I'm going to simplify, and then I do this. I divide by 2 throughout. I will get the same answer. Okay. Okay, last example, example 23. Okay, so example 24. Is it example 23? I think there is. Okay, sorry, example 23. Okay, we are going to do example 23. This is quite simple. Differentiate x e to x. I'm going to have this. Okay, and then I will have this. I think we did this already, right? Yeah, sorry. The last example will be 24. Okay, sorry about that. Okay, now example 24, right? You're going to integrate a trivial function here. Not to worry. Okay, remember that integration of sine is negative cosine. And there's a 1/3 here because this is a 3x here. Okay, and then we just evaluate this function as 0 to pi over 2. Okay, I'm going to take out the constant multiple, negative 1/3. So I'm going to have this. Now cosine 3 pi over 2 is going to be 0. And cosine 0 will be 1. Okay, and when you simplify, you're going to get 1/3. Okay, that's quite straightforward. Okay, for the second one, right? Okay, I propose to actually to take out to break up this integration into 2 parts. Okay, because I want to just take note, this 2 is just going to be 2x. Am I right? Integration of 2 is 2x. Integration of secant squared will be tangent. 3x, 3x, 3 here, 1/3 here. Okay, then I simplify. So I evaluate. This is going to be 2 pi over 3 minus 2 times 0. And 1/3 is a constant multiple. I take it out. I'm going to evaluate this from 0 to pi over 3. So I have 2 pi over 3 here minus 1/3. This is 0, right? So tangent pi minus tangent 0. Correct? And tangent pi and tangent 0 is actually 0. So we have this. Okay? Now for the last one. Okay, I propose to actually take out 2/3. Okay, and this is at the denominator, right? It's going to be x plus 1 if you bring up to the numerator. And integration of ex plus 1, as you know from previous topic, right, is still ex plus 1. 0 to ln 3 here. 2/3 number is here. Okay. This is what we're going to get. Okay. Now, I propose to actually do this. Okay. Why do I do that? Because e ln 3 plus 1, right? I'm going to separate e ln 3 times e1 because this is the same base. Using the index rule, right, we know that this is e ln 3 plus 1. Now, why I want to do that? Because, of course, I just, when it's 0, right, will be e power 1, right? Okay, let's look at this one now. Okay, now e power ln 3 if you take a calculator, right, it's going to give you 3e. It's going to give you 3e. Okay, that's the good part about this. Okay, and sorry, e ln power 3 will give you 3 times e, it will give you 3e minus e. So 3e minus e will be 2e. 2e times 2 will be 4e divided by 3. Okay, because e ln 3, if you use a calculator, right, it will give you 3. Okay, so that's the end of the examples. Thank you very much.